Hello my dear friends, welcome to our channel. So in this session we are going to discuss the fourth property of a charge, that is conservation of charge. And before this lecture we already covered three properties of charges, and our first property is that the charge is transferable, and the second property is charge always exists with mass, and the third property is invariance of a charge. Right, so here we are going to discuss the most important property of a charge, that is conservation of charge. Right, so I'm going to write the statement for the conservation of charge, and everybody knows this statement, that charge can neither be created nor be destroyed, but can only be transferred, from one body to another body, So this statement, everybody would have known this statement, that charge can neither be created nor be destroyed, but can be transferred from one body to another body. This statement, that charge is transferable, it is the same statement here, but this one, charge can neither be created nor be destroyed. We said already this statement before itself, that as the charge is existing in the nature already, right, so we cannot create a charge nor we can destroy a charge. But if you ask that nowadays this statement is correct, so no, if because nowadays charge can be produced, right? There is a pair production phenomena. What production phenomena? Pair production. That means charges are produced in pairs. How the charges are going to be produced in pairs? Right, with the help of gamma photons. Right, here the gamma photons will be there. Right, so with the help of gamma photons, so here some process, some chemical reactions takes place, and this gamma photon is going to give us one electron and one positron. Here we said the charge can neither be created nor be destroyed, we said, but in actual we can create the charge, but in pairs. Then what is the correct statement for the conservation of charge? How to write the accurate statement for the conservation of charge? So let us assume, for example, these gamma photons are going to be in a system, right? So this electron and positron, I got it from gamma photons. So here the net charge of this system is equal to 0, right? Because the gamma photons having no charge. Here the net charge is equal to 0. So as you can see, I not changed the system. For example, if I am having the gamma photons in my water bottle, for example, I am saying, if I am having the gamma photons in a container, the electron and positron are going to be produced in the container after some time, right? After some time, these two are charged particles, what I am getting in the container, but the net charge of the container is still 0. The net charge of the container, just understand, it's very important to understand this one. The net charge of the container which is having the gamma photons, still after producing the electrons and positrons, still the net charge is 0. That means, what does it mean? The total net charge, see, it's very important, the statement is very important. The total net charge of an isolated system, always remains conserved, or you can say constant. You can even write, instead of conserved, constant. Whatever you wish to write, but it should be correct. Here you can see the total net charge of an isolated system. If any system is isolated, or it is always going to be, the net charge is always going to be conserved, the net charge is always going to be constant. That means if this net charge, if this system if this system I'm going to observe after 500 years, I'm going to observe this container. I'm just going to observe the container which is having the gamma photons after 500 years. Still, the net charge is going to be the zero. The net charge is not going to be very, because it is an isolated system. Like the same, this Earth is an isolated system, right? Even 500 billion years ago, the total net charge present inside the Earth, the total net charge present inside this universe is going to be the same now too. The total net charge doesn't vary. The total net charge of an isolated system, any isolated system, always remains conserved, always remains constant. Let us do a problem, we'll come to get the clarity here, right? For example, I'm having an isolated system here. This isolated system having three bodies. Inside this isolated system, they are having three bodies having charges plus 2 coulomb, plus 4 coulomb, and minus 3 coulomb, right? After a time interval of t seconds, I am observing the charges on the bodies got changed. This is body A, this is body B, this is body C, right? Now the body A is having plus 7 coulomb of charge, and body B is having minus 2 coulomb of charge. The charges on the bodies got changed. I'm asking you, what is the charge on the body C after a time interval of t seconds? My question is, what is the charge on the body C after a time interval of t seconds? That means, what is the value of the Q? Right, find out the value of the Q. Just try to solve this problem, right? I'm just going to give you the solution now. Right, what I know, it is an isolated system. It is an isolated system. After t seconds to the net charge of an isolated system going to be same. It going to be remains same. So here, what is the net charge? 2 coulomb plus 4 coulomb, 2 coulomb plus 4 coulomb plus minus 3 coulomb. How much is the net charge? 6 minus 3, that is 3 coulomb is the net charge. Net charge of isolated system Qn 1. Net charge of isolated system 1 is equal to 3 coulomb. Right, here the net charge of isolated system 2. That means here the isolated system 1. That means after a time interval of t seconds, right? It is the isolated system 1 only, but now the charges has been changed. You can see the body A is now having 7 coulomb of charge. So 7 coulomb minus 2 coulomb plus q coulomb. I know the net charge of an isolated system always remains the same. Therefore, I can write instead of net charge on the net charge of the first isolated system is 3 coulomb. So 3 coulomb is equal to 5 coulomb plus q. Q is equal to, here this 5 comes on the left hand side, it will become negative, that is 3 minus 5, that is minus 2 coulomb. That means the body C is having a charge of 2 coulomb. How I said, with the help of conservation of charge. What is the statement of the conservation of charge? The total net charge of an isolated system always remains conserved, always remains constant. Therefore, the net charge after a time interval of t seconds is also going to be the same. That's why I solved this problem. I am not changing the isolated system. The isolated system is a same. Both the systems are same. I'm just observing after a time interval of t seconds. Then you may have a doubt how the charges got changed. See, within the system, the bodies interact with each other. There will be transfer of electrons. Some bodies might lose the electron, some bodies might gain the electron, and the charges on the bodies varies. Inside the system, the charges on the bodies varies. Is the charges going outside the system anywhere? No. Is the charges going outside the system anywhere to buy mangoes, to buy fruits? No. the charges are going to be inside the system. They are changing. That means the electrons are going to get transferred from one body to another body, or they will lose from one body to another body, right? These are the possibilities, but the charges are not going somewhere outside the system. The charges are going to be present inside the system. That's why the total net charge always remains same. The total net charge why always remains same? Because they are interacting with each other. That's why the charges of the bodies is getting vary. But the charges are not going somewhere outside the system. It is inside the system. That's why I'm saying the total net charge of an isolated system, for a system, the net charge remains conserved, remains constant. So it is what about the conservation of charge, and we did a problem based on the conservation of charge. So is the statement, you would have studied this statement. This statement is very important because this statement is the corrected statement. So in the next lecture we will study the last property of a charge, and it is also the most important property of a charge, that is quantization of charge. So if you like this video, then do subscribe, comment with your friends, comment. If you have any doubt, you can comment me in the comment section, and you can ask me in the comment section, and just share it with your friends.